But today what we're going to do is we're going to extend the idea of the mole ratio. We're going to not just go from moles to moles, but when we're in science lab, like if we're doing a chemistry lab, or if we're a chemist, we're going to actually measure out compounds in grams. Like everything that we've done, if we've done a lab, we've measured out what we start with in grams. And so we're going to measure out things in grams, and then we need to be able to predict how many grams of another substance are made. And so this mole idea with mole ratios is going to help us be able to do that. So anyway, like I said, we're typically going to be using grams to figure out the mass of a product that's going to be produced by a certain mass of reactant and vice versa. And so here's like a flow chart. And like I told you yesterday, like I bet you, well, I don't know, but I feel like I was told that other people just have like a chart that shows them how to do this. I'm not giving you a chart. I'm not doing that because that doesn't help you. You're just going to follow the directions and you won't ever use your brain. And if you just do what I'm telling you, you'll be able to do it by yourself and it'll stay with you. So I would rather that. So anyway, we have what mass of water is produced when a car burns 246.4 grams of methane. And so before we do anything, even though we haven't done this before, you still know how to underline and circle stuff. Like you still know how to do that. That is a skill that you can carry with you no matter what kind of word problems you're doing. So what mass of water is produced? And so when I see mass, I'm going to go ahead and put a G there so I know I'm going to grams. That'll just help you in your problem solving. It's produced when a car burns 246.4 grams of methane. Now methane is CH4. I don't expect you to have that memorized at this point. Can I put boxes around anything up here? I don't have a balanced equation. And so let's get a balanced equation. So combustion is a hydrocarbon plus oxygen in this case. And that's going to give me carbon dioxide in water. And I'm going to show you my little balancing trick with combustion. I get an email every day, like an AP Chemistry, like email of the day question. And today's question related to this trick. And it's just a very common thing that I see all the time. So anyway, carbon is going to be the same. So I have one carbon and one carbon. I don't need to add a coefficient there. And then my hydrogen, I'm going to use half of that over here in the water because it's going to get multiplied by 2. So look, I have 4 hydrogens, I have 4 hydrogens, I have 1 carbon, I have 1 carbon, and then I just take care of my oxygen. And so if I do my math, I have 2 plus 2, oxygen is 4, 2 times 2 is 4. So those combustion ones are a lot faster that way. Just a good thing to know how to do. Anyway, if I actually go ahead and read my question now, I'm going to box up the methane, and I'm going to box up the water. So I see that I have 1 mole of methane reacting to give me 2 moles of water, basically. So if I wanted to write a mole ratio here, I'd have 1 mole of water, 2 moles of water for 1 mole of methane, or vice versa, 2 moles of water for, I don't know which one I said, but the other one. Flip it upside down. So when I go over here, I'm just going to leave that written on the board, and I'm just going to go over to my little camera, and it'll stay there. Let me make that bigger. So let me kind of show you why we've been doing this thing on our hands. And it's helpful with the conversions we've been doing, but here we go. What we've been doing is we've been just dealing with one substance, okay? So if I want to go to grams of one substance to moles or formula units, that's there. And you're going to have to do that on your quiz tomorrow. Like if you're dealing with just water, you're going from grams of water to molecules of water or whatever. That's just this. So that is on your quiz tomorrow. But what we're doing today is we're adding to this. And so what were we solving for? Grams of water? Okay, so if I'm trying to get to grams of water, I have to start with grams of methane. Grams of methane to moles of methane, that's one step, right? So if I need to get to, if I go to atoms of water, like that's not helping me. I mean, atoms of methane, that's not helping me. So I need to get to water. And so the way I'm going to do that, like I said, I would put our hands together, right? So that's 2 steps. Then I'll be to moles of water, and then I'm still not done. I'll have to go to grams of water. So if I start with grams of methane, go to moles of methane, that's 1 step. Go to moles of water, that's 2 steps. Go to grams of water, that's 3 steps. So that's the idea. And so this little hand thing is helpful, handy helper. It's going to help you get from one substance to the other. And so, to be honest with you, at this point, we really won't need, for stoichiometry, which is comparing reactants to products, you won't really need this little Family Guy anymore. You won't need, that's a TV show, and you won't need formula units and atoms and stuff like chemists when they're actually doing reactions. But they're not counting up atoms. That's like not realistic. So your Avogadro's number for mass to mass stuff, when I'm going mass to mass, you're not going to use 6.022 times 10 to the 23rd because that many grams again weighs more than a moon, right? So that's not a good idea. So we're really just going to be using those molar masses. Okay. So let me kind of work this one out for you and show you how we're going to do this. And I'll keep pointing to your hands. And I don't think, after a day or two, you won't need what you've written on your hands anymore. It'll just kind of be internalized. There's a good amount of research on that, which I find to be interesting. If you do the hokey pokey enough, you don't need to, the steps. So anyway, I'm going to go ahead and start with what I underlined, just like I always have. So anyway, I keep messing up this math. 246.4 grams of water. I'm starting with what I underlined. Just like always. No big deal there. I wrote a little bit too big. This has 3 fractions. I know I have 3 steps, right? So I'm just going to make it a little bit smaller because if I don't, I'm going to run out of room. Okay, so I'm at grams of water. I need to go to moles of water. If I want to go to moles of water needs to be in the top right-hand corner. This is the same thing as grams of methane. Thanks. Thank you. All right, now here's the thing. I'm glad I did that. And I'm not just trying to play off my mistakes. When I'm doing chemistry problems, I make mistakes. I don't want to say all the time, but I make a lot of mistakes. But I never make it to the end with my mistakes because I have so many checkpoints. When I got to the end, I would have seen that water didn't cancel. I know what I'm looking for. I circled it. I circled it on my last step. So if I had done that and carried it through, I would have caught my mistake. And so I do a lot of self-checking because, I told her this, I've never made a B in my life. And it's not because I'm lucky or I'm a genius. It's because I'm not trying to halfway do something. I'm going to check my work and think about what I'm actually doing. So anyway, put that over 1. That was the whole purpose. So I'm going to moles of methane. And so that's 1 step. So I know I need moles of methane. Now, y'all, take this out of context, okay? Let's take this back to before spring break. If I ask you to go to moles of methane, what would you do? You'd just be like, right? And then you'd find the molar mass. And the molar mass of this, you got 1.008 times 4 plus 12. So let's do that. Is our periodic table 12.01? Oops, I'm over here adding all kinds of stuff. It's 16, but I'm trying to give you the right number that y'all are wanting. So 16.042 grams of methane. This right here, this is nothing that we haven't done over and over again. If I asked you to go from grams of methane to moles of methane, you would do that. Let me tell you what you're going to try to do. What you're going to try to do, because we did that mole ratio yesterday, you're going to try to use these coefficients in this step. When you're adding up the molar mass, you are finding the mass of 1 mole. Not 2 moles, not 3 moles, 1 mole. This part where you're doing stuff on the periodic table, that's going to have 1 mole. If you mess up on this, it's going to be because of that. So, this is nothing other than we've done 1,000 times. Or maybe 100. Or a dozen. So, are you okay there? We're at the palm of our hand. We're at moles of methane right now. Cancels, cancels. Y'all all right? So now I have 2 choices. I can go to atoms of methane or molecules of methane, or I can go to my other hand. So is that helping me to go to molecules? That doesn't help me at all. So I want to now go to moles of water. And so I'm going to do that. I have moles of methane, and I need to go to moles of water. If I have to go from moles to moles, that's where our mole ratio comes in from yesterday. Okay, so up here in my balanced equation, I have 1 mole of methane. And then for every 2 moles of water. Left out a word. Okay, so here I am. I went from grams to moles. Now I'm at moles of water. Yes, ma'am. Yes, ma'am.
Can you have Ellie Zarin come to the front office, please?
Does it have to be right now?
Please.
Yes, ma'am.
Thank you.
Take it past the window. All right, anyway, so now I'm at moles. I'm at this part of my hand. I want to go to grams of methane. And so when I do that, I'm going to 1 mole of water. This is, when I'm going from moles to grams, I'm going to use 1 mole. I'm going to add it up from the periodic table. When I do that, I get, it's 18, but, you know, to be a little bit more accurate for you. Dang it. And so moles cancels. This mole to mass conversion, notice again, I'm doing 1 mole. The only place that you use those coefficients is this mole ratio. Everything else is just always going to be 1 mole. 1 mole is Avogadro's number. 1 mole is the mass from periodic table for molar mass. The only place you use those coefficients is that mole ratio. Okay, everything else 1 mole. And honestly, like if you got confused right here and you did 2 moles of water, if you added it up and put a 2 down here and this was 36, it would come out all right. Because that's the same, when you divide it out, it ends up being the same number. But bottom line, this is 1 and this is 1. So now I'm going to multiply across the top, multiply across the bottom, and divide. And, I mean, I can kind of, you can sort of go through this in your mind. If I'm starting, let's see, with 246 grams of methane, you can tell, like, for every 1 methane mole, you get 2 moles of water. And so I should have, and the molar masses are real similar. They're like 18 and 16. So you should have about twice as much. The molar mass of water is a little bit heavier. So your answer should be like 500, maybe 520 or something. Is that, am I making stuff up? Huh? All right, great. So, and then I need 1 more sig fig, right? 4. Now, I wasn't exactly on it, but I had no calculator, and I did that in my head just real quick. So when you're doing these, you can kind of check your math to kind of make sure if it works out. Now, some of them get kind of complicated. I'm not going to lie to you, but it's good to see if it's in the right ballpark. Yes, sir. Do you have a question? Okay, so here's the thing. These are all infinite. Conversion factors are infinite, so I'm limited by what I start with. So, you know, 1 foot is 12 inches, it's infinite. This is molar mass, mole, infinite. So you're not limited by that. You're limited by the one with the fewest. Anybody else? How do you feel about that? I'm going to do some more. Let y'all get this down. I see some of y'all writing. So bottom line is you already knew how to do this. And we just added in the mole ratio. That's all we did. Just a little bit more work. If I had shown you this about 2 weeks ago, I think you'd have cried, but it's fine. So, just a little bit. Okay, so y'all got that down? Questions? No? Need some more time? I tell you what, Kenneth, as I click through it, it'll put it back up and it might be a little bit easier to write down. It's a little bit neater. They're little PowerPoints. Be a problem solver. I like it. So you can see, you know, if you can't bounce the equations, you're going to, all of this work is going to be off because your mole ratio will be off. And so just, that's going to be an important step. You can go ahead on your paper and start underlining and circling the things in the next question. Okay, boxing this stuff up. I mean this in the nicest way possible. If I come around today and I'm looking at your paper and you're not writing down methane, water, iron, you're not writing down the elements and compounds, I'm going to be a little bit sassy with you because I've graded enough papers to know that that's why people mess up. They don't feel like writing down 2 letters. All right? Welcome to high school. Welcome to life. All right, so we need to go ahead and try to write this balanced equation for the next one. That's a good critical reading skill. I believe you can write the balanced equation okay. You try to work on it on your own quietly, and I'll write it up here, and you can check when you're done. I'm going to talk you through balancing this one because it is kind of tricky. You can see how everything starts to really pile up on you at this point in the semester. Okay, I see some good work. I see some people that might need a little bit of help. If you read the wording here, how many grams of carbon dioxide and iron are produced? Did I write this? No, I didn't write. So carbon dioxide and iron are produced. So they're my products, right? When I saw some people writing them on the reactant side because they came first. So you have to be careful. So when 114 grams of carbon monoxide is added to a vessel containing excess, remember that seems to have enough, or extra, of hot iron 3 oxide. And so, you know, that's kind of what we're looking at. Now it's not balanced, so we do need to do that. Remember when you have a lone element, it's very helpful to put that last when you go to balance. Oxygen's in 2 places over here, so I think I'll put that second to last. So anyway, have carbon, oxygen, and iron. And I'll work this out. If you want to watch, you can. If you'd like to do it yourself, you can. So I have 1 carbon, I have 4 oxygens, and I have 2 irons. On this side of the equation, I have 1 carbon, 2 oxygens, and I have 1 iron. So the carbon's okay for now. I do need more oxygen, so I'm going to put 2 here. That gives me 4. And then my irons, I'm going to go ahead and put a 2 there. Then I'm going to go... when I fixed it, I didn't put it 2 here, so there. That gets me through those, kind of 1 time each. My carbon is no longer equal, and I have to have the same on each side. So anyway, if I go right here, I can already see this is going to be a problem because I'm about to add 3 oxygens to it. This one is kind of one of those tricky ones. So anyway, if I put a 2 here to give me 2 carbons, then guess what? I'm going to end up having 2 plus 3 oxygens, which would be 5. And I'm not going to be able to have an odd number because this is going to be times 2. Not that I can times by 2 and get 5. I mean, not that we want to deal with right now. So, anyway, I'm going to go ahead, you know what I'm going to do is I'm going to do 3 because 3 oxygens plus 3 oxygens, that'll give me 6, and I feel like that would be better. So, it's kind of experimental. You kind of play around with it. But I'm going to put 3 carbon monoxide, so that'll give me 3 carbons. And that will give me 3 plus 3 oxygens would be 6. So if I look right here, I do need 3 in front of my carbon dioxide. That'll give me 3 carbons. And it'll give me 6 oxygens. And then my irons are they're balanced. So balance is kind of hard, but you know, you can work through these. So balanced equation. So this is just old stuff. Nothing new here. Someone asked me earlier in today, what did they ask me? Oh, to re-explain the Roman numerals. So remember the Roman numerals on the chart. And so if I had iron and it was 3 plus, each iron is 3 plus, and oxygen is 2 minus, then I would need 3 oxygens and 2 irons to be able to, yeah. So anyway, so there's the balanced equation. Go ahead, if you haven't already, and underline you know, what we're going to be, underline and circle what we're going to be working with in the rest of the problem. This is 2 separate problems. This is we're solving for carbon dioxide. and we're solving for iron. We're going to have to do that in two separate problems. So this is basically like two practice problems put together. So go ahead and check that out. I can already tell that I'm going to start with 114 grams of carbon monoxide. And I'm going to be solving for grams of carbon dioxide and be solving for grams of iron. And here's the thing. Go with me now. If I'm starting with 114 grams of carbon monoxide, how many hands do you have? You just have 2 hands. And so you're not going to be able to do this in one step. You're going to have to go start with carbon monoxide and solve for carbon dioxide. Do it, get an answer, done. Then you're going to have to start over. Carbon dioxide on this hand, carbon monoxide on this hand to solve for iron. Okay? I'm going to just, all the way through, I'm going to work out the carbon dioxide one. And then I'm going to let you try the iron one. Okay? So I'm going to start with 114 grams of carbon monoxide. Please notice I'm writing down the elements. Okay, I love you. Thanks. So I'm here on this middle finger for grams. I'm going to moles. So I'm going to moles of carbon monoxide. So 1 mole of carbon monoxide. Somebody asked me why do I drop the E on mole? Because that's the abbreviation for mole. Yeah, mole has an abbreviation. Molecule doesn't. That's hilarious, but it's true. So anyway, carbon monoxide, it's like 28, but 12.01. 16. So 28, my pen died. So 28.01 grams of carbon monoxide. So I'm on the palm of my hand, grams cancels, and I'm left with moles of carbon dioxide. So I'm at moles of carbon dioxide, don't need to go to molecules, that's not helping me, that doesn't help me, that's not getting me to where I want to go. So I'm going to go to moles of carbon dioxide, and be able to go from moles to moles. That's where that mole ratio comes in. And so anyway, I have 3 moles of carbon monoxide, and I'm getting that from the coefficients of the balanced equation. And for every 3 moles of carbon monoxide, I have 3 moles of carbon dioxide. You know, if you're thinking mathematically and you're like, well, that reduces down to 1, you're right. That's fine. But what happens is people, when they do these problems, they just put 1 and 1 automatically. Like, that's a very common error. So I'm not going to reduce it here. I'm going to write what's in the balanced equation, and it'll come out in your calculator, and it'll be fine. Okay. So anyway, I'm at moles of carbon dioxide now. I'm going to go to grams of carbon dioxide. So 1 mole carbon dioxide weighs 44, and it should be 44.01, I think, with your periodic table. Or maybe it's, no, that's probably right. So anyway, moles of carbon dioxide cancel. Moles of carbon monoxide cancel. Mole of carbon dioxide cancels. And I'm left with grams of carbon dioxide, which is what I was wanting. So now it's just a simple step of doing some math and getting an answer here. And it looks like I get 179.1 grams carbon dioxide. And let's talk through if that makes sense. If I start with 114 grams of carbon monoxide, and for every 3 moles of carbon monoxide I have, I get 3 moles of carbon dioxide. Carbon dioxide weighs more, doesn't it? See how it weighs 44 instead of 28? So you would expect your answer to be heavier, and to the tune of about, 1.5. So that answer makes sense. How do you feel about that? Are you okay? All right, so the second problem when you're solving for iron, it's the same problem, except, you're going to start over and go to iron. So I'm going to leave this up here so you can look at it and finish up, and I want you on your own to try to solve for iron for me, okay? If you feel good, you can go ahead and go on to that last problem if you want to. Last week, they were there, and I bought some purple markers from them. They were really nice. We need to put the purple markers out because we don't have enough markers in these letters. Did you go ahead and sell for iron? You can go ahead and start looking at that next one, and I'm going to work out iron up here so you can check your work. Actually, I can just play it out for you. That'd be fine. So let's check our work on the iron. There's the balance equation, and so our carbon dioxide was good. And then here's the work for iron. You should have got 152 grams of iron. Watch your sig figs. They both should only have 3. I'll leave that there for a second if you need it. Yes, sir? Okay, you're fine. Take your time. Here I'm starting with grams. I need to go to moles. And like I said, these molar masses are going to always be for 1 mole. These are the coefficients for my balance equation. And this is, again, my molar mass. So you start the same way. You start with carbon monoxide. Right. Okay. So you start there. You don't need the all of this. You don't need this anymore. So you do this exactly the same way. And now go to iron. Okay, just do the exact same. Yeah. Okay. So this one, I can see that can be a little too dry. Yeah. So you just go on to start all of it. Okay. So you're just doing basically the same thing. Thanks. So I see a couple people still working on the iron. That's fine. If you're finished, you can go ahead and start looking at the next question. Remember, bicarbonate has a hydrogen in it. That's the difference between carbonate and bicarbonate. carbonate, that's sodium carbonate. 5 has hydrogen. And that's why we're going at that hydrogen the charge is made, and that's why we have 1 so there, we're going to put 2 there. I think everybody's good on the iron. Or almost, and that's okay. I'll leave it up here for another minute. And I see most of y'all have started on the next one, and that's okay. So I'll work that one out in completion. There you go. Thank you, ma'am. So let me kind of talk you through this one because I'm about to let you loose. If you got it and you're working and you're happy, then fine, do that. So I can already tell mass of sodium bicarbonate. That's going to be grams. And the bicarbonate, sodium bicarbonate is NaHCO3. And then this is sodium carbonate. There's a difference, okay? So anyway, I know that I already have a balance equation, which is really cool, thank God, right? And I was telling somebody earlier this morning, like, the balancing equation part is hard, and finding the molar mass, that's kind of annoying. And in AB chemistry, to be honest with you, like most of the time they give it to you, they give you the molar mass, they give you the balance equation, because there's just like so many other fish to fry. This is just a good basic skill. So anyway, I want to start with 32 grams of sodium carbonate. And notice that I have to have 2 sodiums with the carbonate, because carbonate's 2 minus. But when I add that hydrogen and get bicarbonate, it becomes 1 minus, because that H has that 1 plus charge, right? So anyway, I want to go to moles of sodium carbonate. So I'm going to try to write this kind of sideways because I'm going to run out of room. Molar mass of this, anybody got it already? Oh no, 5 point. Okay, thank you. And that's sodium carbonate. And yes, it is annoying to write down that over and over again, but it's going to keep you from messing up. So I'm a big fan of that. Now I'm to the palm of my hand on my moles. I got to go to the moles of the other one. And so now I have 2 moles of sodium bicarbonate for every 1 mole from my balance equation of sodium carbonate. And now I'm at the palm. I need to go to grams. Bye. I need to go to grams, and so 1 mole of sodium carbonate is something a little bit heavier. Oh, I'm missing an H. Yeah. Something happened. But that's okay. Well, so let's see what I have here. My mole ratio right here, I can find my error. So right here I needed to have that Na2. But do you see what happened? Like I found where I messed up before I got too far. It's a good little skill. And I'm going to sodium, bicarbonate. And so if I get rid of this and fix it. And so now I'm in the right place. This one's tricky because it's like sodium carbonate and sodium bicarbonate. That's, you know, probably not the best, you know, 2 compounds to be working with today. So anyway, the molar mass of that one, this should be a little bit lighter.
Yeah, it should be 2 over 1. Yeah.
Oh, when I rewrote it, I didn't fix it. Okay, gotcha. Thank you, guys. I'm awful smart. I just showed you this today. Good. All right, good. So this is, if I look at my balance equation, I do have 2 moles of sodium bicarbonate. Sorry, you guys. For 1 mole of sodium carbonate. Now we should be good, I think. And then I need the molar mass of this, which is 84. I tried to, did you see me try to save it? 84.0. And I'm solving for sodium bicarbonate. Okay. Thank you. And so that's the setup, and I'm gonna, this is a hot mess, so I'm just gonna move to the electronic setup so it's a little bit cleaner for you. And then your answer turns out to be 51 grams. And notice you can only have 2 sig figs. because you started with 2 sig figs and your conversions are infinite. So I'm going to leave this up here. I'm going to give you guys about a 5-minute start and a head start, and then I'll put it start the answer key for you, okay? Oh, that one was. Appreciate you find an article on here. You can answer that. So they're being pretty.
I already found an article that's
I'm having a psychic vision about 3 of them in that class that just like,
I didn't even know we were supposed to get animation toys until like I got moved. Like, yeah,
Kara was like, hey, he's funny.
yeah, that's usually how it is.
I mentioned it in the class yesterday.
Yeah, sure.
I would update the calendar to make it really whiteboard so I can have to put it on this. Your stuff was on there.
Why are they getting rid of it? They just use it like
It
every
was
day last
really,
year.
well, I didn't feel a lot, but then what happened is it's just random events. And so whatever I have, they have not transferred over, so I'm not trying to. Alright, I think that's enough of a head start. I was, get you guys. Yeah, it has some typos.
Whatever.
Yeah, you sure do. And I'm just going to scroll through this. If anybody's watching the video, they can just pause the video, and I'll turn the video off. Like I just... No, I'm thinking it'd be okay. I think you could hit pause. I think it'd be alright. Be just fine. Yeah. Yeah, it's fine. You know what? When there's a will, there's a way. You'd be alright.